And now I need to actually decide, is it twice as far? So let's think about, our work is our change in kinetic energy. This guy had 1/2 mv squared and 1/2 m root 2v squared. So see how this has twice the kinetic energy as before? Or you could say it has twice the potential, twice the height, which means twice the kinetic. So my work done is going to be twice as much. The force of friction times the displacement. I'm not going to call it d here because this is actually like 4d, etc. So I'll just call it delta x. The force of friction should be the exact same as before because you still have the same coefficient of friction, the same mg, right? The same normal force. But now if I have twice the kinetic energy, see how that's going to need twice the displacement? The original displacement was 40, so if you're going 40 and you double it, now it's going to be 80. So it will slide farther to end at 80. This one, it literally said which aspects are correct. It didn't even have me explain why they're correct. So what's correct is twice the height will mean more energy at the bottom, which is faster. It will take slide farther to end at 80. What is not correct is it will not be twice the velocity at the bottom. Now it says derive an equation for the new final position of the block. So my answer is going to be the 80 because we just said that we agree with it. We just got to show our work now. So the work is equal to change in energy, which is equal to FD. I'm going to do the first scenario, so work in the first situation. I'm going to call this delta x actually. The work done is just going to be the change in energy in the system. So you can do the kinetic at the bottom, right? Or you could do the, what's it called? Potential at the top, because the kinetic at the bottom is equal to the potential at the top. So at first I started with mgh, and then I lost all of it. So I went to 0, so then my change is mgh. Force of friction, and the original one was the 40. Now in the second scenario, right, the energy we lost, delta x2, the energy I lost was actually mg2h. And if I have the exact same friction force, see how this is 2 times the change in energy, which will be 2 times the work, which will be 2 times the displacement. The original displacement was 40, so then that's going to be 80. So this one, my deriving equation is a little bit of an explanation because I'm saying, hey, that's twice the height, which is twice the potential, which is twice the kinetic at the bottom, which means I lose twice as much energy. So with the same force, you would need twice the distance. Yep. In the following question, refer to any relationships that I wrote in part C, not just the final answer. For any correction, I think that was supposed to be correct aspects of the student's reasoning, identify in part B1, how is the student's reasoning expressed in your mathematical relationships in part 2, and what is incorrect in part B. So for correct, we said that twice the height would be twice the energy. So twice the height will be more energy at the bottom. So mgh for energy in the first scenario, and mg2h for the energy in the second scenario. That will be moving faster, which will be, what did we say was correct? I can't remember. That will slide farther along before stopping at 80. So will slide farther, 2 times the displacement, to end at 80. What was incorrect, and we did this on the other page, what was incorrect is not 2 times the velocity, because mg2h equals 1/2 mv squared is only root 2 times v1. So I am looking at what I wrote, and some of it I actually wrote on the last part right here, and I'm using like words to explain how this right here is what we said was correct or incorrect from before.